Hello dear viewers, welcome to TV Math Hub. In our today's session, we shall be looking at the question number 11 for Uneb 2025 Pure Mathematics. We have so far looked at the solutions to questions from 1 up to question number 10. And please check our previous videos. And I will also attach the link to the description of this video. Please check out the solutions to these questions. So let us look at question number 11. So we are told to differentiate the following with respect to x. We have y, which is equal to ln of e to the power 3x divided by cos of 2x. And we shall differentiate this with respect to x. So without wasting time, let us look at the solution. So when we are given y as that, looking at the function we are given, this is a logarithmic function, which can easily be simplified by using logarithmic properties before we differentiate. So before differentiating, let us try to simplify this by using the log properties. And this will be same as having y, which is equal to a ln of e to the power 3x. When we are dividing, it means we are subtracting here. So that is ln of cos of 2x. So from here, it is important to note that if you are having a ln, of a divided by b, this is same as ln of a minus ln of b. And likewise, when you are having ln of e to the power k of x, this is actually same as having k of x. So when we have ln of e to the power 3 of x, we can write this as 3x minus ln cos of 2x. So from here, we shall differentiate. We shall differentiate each term with respect to x. So next step is differentiating. Next step is differentiating each term with respect to x. So when we do that, we shall be differentiating with respect to x here, y. We shall be differentiating with respect to x here, 3x. And then minus, we differentiate with respect to x, ln cos of 2x. So this will be giving us dy dx. And this will be equal to, when you differentiate this, you get 3, minus, when you are differentiating ln of a function, you differentiate that function, then you divide by the same function. So in other words, it is same as differentiating cos of 2x, then you again divide by cos of 2x. That is how we differentiate what we call a ln function. So this will be same as having 3 minus differentiate cos of 2x. So you differentiate this one here. When you differentiate 2x, you get 2. So there it is same as applying the chain rule. So the derivative of cos 2x will be differentiate this. It will give you 2. And then we shall multiply by derivative of cos, that is negative sine. So that is negative sine. Then return the same angle, that is 2x. So we are dividing this by cos of 2x. So in other words, we shall be able to get this simplified to give us 3. This will be plus 2 sine of 2x divided by cos of 2x. So, but we know sine 2x over cos 2x is a tan of 2x. So we can have this as 3 plus 2 tan of 2x. And this will be dy dx. So therefore, this implies that when you differentiate this function with respect to x, you get 3 plus 2 tan of 2x. And that will be the derivative of y with respect to x. Now looking at part 2, we need to differentiate y equaling to sine squared of 5x squared plus 4. And we shall look at the solution. So when we look at the given function, this is actually a composite function where we can easily use what we call the chain rule. So what we shall do first is to let u to represent 5x squared plus 4. And if u represents that, it implies that y will be same as sine squared of u. Now for that case, we shall differentiate u with respect to x, and this will give us 10x. At the same time, we shall differentiate y with respect to u. So y with respect to u, we shall drop this 2 here, then reduce the power by 1, so that is sine of u. Then differentiate sine function and get a cos of u. So when you have 2 sine u cos u, this is same as sine of 2u. and this will be dy du. So having got dy du and we have du dx, so we can use what we call the chain rule here. So from here we can get dy dx, and dy dx will be same as dy du times du dx. But dy du is a sine of 2u, and du dx is a 10 of x. Please don't multiply this with this. So it is better to have 10 of x out than sine of 2u. But since we are given our expression in terms of x, then we shall have this as 10x, then a sine of 2 into u. U is 5x squared plus 4. So in other words, we can therefore have dy dx as a 10x, then a sine of 10x squared plus 8. And that will be the required solution. So from there, we have so far looked at part 1 and 2, that is for part A, and now we can come to part B. So part B says a curve is defined by the parametric equations, x equaling to this and y equaling to that. Find the equation of the tangent to the curve at the point which is 2 and 3. So looking at the solution, we are told that we are interested in the equation of the tangent at this given point. So to get the equation of the tangent, we must know the gradient of the tangent first. And to get the gradient of the tangent, we must know dy dx. So for that case, since we are given x as that, we can get dx dt. What will be dx dt? Dx dt will be same as 6 t squared, and dy dt will be same as 8t, then minus 4t to power 3. So from this, we can get a dy dx, and dy dx will be same as having dy dt times dt dx. So when we look at that, what is dy dt? That is 8t minus 4t to power 3 divided by, or else we can maintain the multiplication. So let us maintain the multiplication times dt dx. Dt dx is same as the reciprocal of dx dt. So that is 1 upon 6t squared. So this will give us 8t divided by 6t squared minus 4t to power 3 divided by 6t squared. Remember, each of these is divisible by this expression. So for that case, we shall be able to get, let us put by 2, this will be 4 over 3, and the t will be 4 over 3 times 1 upon t. Then we shall be subtracting by 2, this is 2 over 3, and this will be t. So this is t. So this can as well be written as 4 over 3 t to power negative 1 minus 2 over 3 t as dy dx. So dy dx is in terms of t. But since we need the equation of the tangent at this given point, so we must get the value of t that we shall come and substitute here to get the equation or the gradient of the tangent. So let us look at how best we can get a t. So we are given that we are interested in the equation of the tangent at this point. So at 2, 3, it implies that x is 2 and y is represented by 3. And for that case, it means, since we have x as this, so it means from x equaling to 2t to power 3, so 2 will be same as 2t to power 3. So t to power 3 will be equal to 1. And this implies that t will be cube root of 1, and this remains 1. So t will be equal to 1. So likewise, we need to check whether it will satisfy this given expression as well. So we need also to check. Let us try to check. Let us try to check y. Let us try to check y. So from also y equaling to 4 t squared minus t to power 4. So y is given at 3. So 3 is same as 4t squared minus t to power 4. So from here, it means we need to solve this So this is same as having t to power 4. This is same as having t to power 4 minus 4t squared, then plus 3, which is equal to 0. So let us try to simplify this and see whether we shall be able to get the same value for t. Now, from this given point, we can try to let t squared to be equal, for example, p. And for that case, we shall have this as p squared minus 4p plus 3 is equal to 0. So let us solve this. So we have p squared minus 4p plus 3, which is equal to 0. And that is basically what we need to solve for the values of p. So from here, we can easily get the factors of 3, which we can add together to give us -4 and multiply together to give us 3. So that will be -1 and -3. So it means p squared minus p minus 3p plus 3 will be equal to 0. So p into p minus 1, open the same bracket, p minus 1. So here we shall place there -3 will be equal to 0. So p minus 3 into p minus 1 will be equal to 0. So this implies that p is 3 or p is 1. But remember that p is same as t squared. P is same as p squared. So t squared is same as p. So p is same as t squared. So it means for p equaling to 3, t squared will be equal to 3. And for that case, it implies t will be equal to plus or minus the square root of 3. And likewise, for p equaling to 1, t squared will be equal to 1. And this implies that t will be equal to plus or minus 1. So from the values of t that we have got, here we have t as 1, and here we have t as 1 or -1, then root 3 and negative root 3. So for that case, it means the one that will be satisfying all the two, it means it will be t equaling to 1. So we shall be saying that therefore the point will be corresponding to the point corresponds to t equaling to 1. So if that is the case, then what will be the gradient of the tangent? So the gradient of the tangent will be the gradient of the tangent is m, but this m is same as dy dx, which dy dx we got it as we got this from equation star 4 over 3 t to power -1. This is 4 over 3. Actually, let us maintain it down, 4 over 3t. Then this is minus 2 over 3t, minus 2 over 3 t. So let us look at dy dx at the point when t is equal to 1. So this will be 4 over 3 times 1 minus 2 over 3 times 1. So this is 4 over 3 minus 2 over 3, and this will give us 2 over 3. So we shall get the gradient, therefore the gradient of the tangent, is m, which is 2 over 3. So after getting the gradient of the tangent, we can now obtain the equation of the tangent line, which is passing through the point 2 and 3. So next, let us look at we shall talk about the equation of the tangent line. So the equation of the tangent, to the curve at the point which is 2 and 3. So far we have got our gradient, which is 2 over 3, and we have our point which is 2 over 3. So we shall be saying from a gradient which is same as y minus y1 over x minus x1. Y and x are points. Xy is a point, is a general point on the tangent or on that line. So this should be equal to the gradient. So meaning that y minus 3 over x minus 2 will be equal to 2 over 3. Cross multiply, this will be, this will give us 3y minus 9, which is equal to 2x and then minus 4. So 3y will be equal to 2x. This is negative 4 plus that will be positive 5. So this implies that y will be equal to 2 over 3 of x plus 5 divided by 3. So that will be the equation of the tangent. Therefore, the equation of the tangent, the equation of the tangent to the curve at the point 2 and 3 is y, which is equal to 2 out of 3, x plus 5 out of 3. And that will be the required answer for 11 part B. So question 11 will be done. And please, if you find this video helpful, don't forget to subscribe to this channel. Don't forget to like and share with your friends. So let us now look at question number 12. Next question, we shall look at question number 12, which says find the Cartesian equation of the plane that is passing through the points A, B, and C. So looking at the solution, we need to obtain the equation of the plane that is passing through A, B, and C. And for that case, to do that, we shall first of all get the vectors. So let us find the vectors. Let us find the vectors AB, the vector AB and AC. So let us find the vectors AB and AC first. So AB, vector AB will be same as having B minus A. So that is 3, 1, and 9. And we shall be subtracting, that is OB minus OA, that is 1, 2, and 3. So doing that, we shall be able to get 3 minus 1, that is 2, 1 minus 2, that is negative 1, 9 minus 3, that is 6. So it means our B will be 2, negative 1, and 6. Doing the same for AC, we shall be getting C minus A, negative 2, 1, and 3. We shall subtract A, which is 1, 2, and 3. So this will give us negative 3. This is negative 3. 1 minus 2 is negative 1. And 3 minus 3 is 0. So we shall get negative 3, negative 1, and 0. So from that, this will help us in obtaining what we call the normal vector. So we shall look at the normal vector. The normal vector n is actually obtained by getting the cross product. Is the cross product AB across AC. So it means we can easily get our n by taking the cross product of AB and AC. So we shall have I, J, and K. Then AB is 2, negative 1, 6. AC is negative 3, negative 1, and 0. So from here we can obtain this as I into, let us eliminate this and this. When you eliminate the first row, first column, you remain with negative 1, 6, negative 1, and 0. Then minus J, this is into, eliminate this and this, eliminate the first row, second column, remain with 2, and negative 3, 6, and 0. And lastly, we shall have K, eliminate this and this, you'll have 2, negative 1, negative 3, negative 1 as the determinant of that. So this will be I into, this is 0 minus negative 6, 0 minus negative 6, minus J into, this is again 0 minus negative 18, and again this is K This is -2 minus positive, this is +3 minus 3. So this will give us 6i. This is minus, this will be plus, that is minus 18j, and plus, actually it will give us a minus because this is -5. So we shall have minus 5k. And this will be our normal. So our normal will be 6, -18, and -5. So what will be the equation of the plane? So let us get the equation of the plane using the point. Let us get the equation of the plane using the point, which is A, as the point on the plane. And for that case, we shall be saying that from the general equation of the plane, which says that if you have r dot n, this is same as this is equal to a dot n. So where r is a general point on our plane, point A is the point we shall be considering this one, then n is what we have obtained. So in other words, we shall use the equation of, we shall get the equation of the plane using the point. So let us put that. So the plane equation using a point A, and that point A is 1, 2, and 3. So we shall be referring to this using this point. So let us look at that. R is the general point. So for that case, the general point on the plane is R, and R is same as X, Y, and Z. We are dotting this with N. N we have got it as 6, -18, and -5. So this is 6, -18, and -5. So this should be equal to 1, 2, 3. And we are dotting this with n, that is 6, -18, and -5. So this will give us 6x minus 18y minus 5z, and this is equal to 6 minus 36, then minus 15. So this will give us 6x minus 18y minus 5z, which will be equal to, so this will be equal to negative of 45. So negative 45. So therefore, the equation of the plane passing through the points A, B, and C will be, so we can give the general conclusion that therefore the equation of the plane passing through points A, B, and C is 6x minus 18y minus 5z plus 45, which is equal to 0. And that will be the solution. So next we look at part B. Part B says determine the angle the plane in A makes with this line here. So for that case, we need the angle between this plane here and the line which is given. So we need, in part B, we need the angle between the plane, which plane is 6x minus 18y minus 5z plus 45 equaling to 0. So we need the angle between this plane and the line, which line is given as x minus 2 over 2, which is equal to y plus 1 over 0, which is equal to z plus 3 over -1. So that is the line that we are given. So for that case, let us see how do we get the angle between a line and a plane. So the angle between a line and a plane can be easily obtained from, if you have a D, which is representing the direction vector. So this is representing the direction vector of the line. And you have N, which is representing the normal. vector, of the plane. Then you can easily get the angle by looking at the expression that n dot d is equal to magnitude of n times magnitude of d. And then here we use what we call sine of the angle. So if the angle is between a plane and a line, here we use a sine. So for that case, let us look at n. What is the normal to the plane? The normal to the plane is actually 6, negative 18, and negative 5. This one here, 6, negative 18, and negative 5. So that is what you pick. And again, d, the direction vector. So if we have that, if d is representing the direction vector of the line, is obtained by taking these values here. So that will be 2, 0, and negative 1. So for that case, we shall substitute in this given expression. So the angle, because we have seen that the angle between the plane and the line satisfies this given expression. It satisfies this given expression. That is n dot d is equal to magnitude of n dot magnitude of d a sine of theta. So for that case, let us obtain n dot d, or we substitute in this given expression. So let us try to substitute in this given expression. So what is n dot d? So substituting for n dot d, so we are saying from this equation star, we are having n dot d. Our n is 6, negative 18, and negative 5. We are dotting this together with d. D is the direction, a vector of the line, and that is 2, 0, and negative 1. So this must be equal to the magnitude of that. Magnitude of this is same as having 6 squared plus negative 18 squared plus negative 5 squared. Then we multiply this by the magnitude, that is the magnitude of d. So the magnitude of d for that case is 2 squared plus 0 squared plus negative 1 squared. Then we multiply by sine of the angle between the line and the plane, which is theta. So let us try to simplify this. This will be 12 plus 0 plus 5, which is equal to, let us simplify what we have here. So when we try to simplify this, we shall get 385, and 2 squared plus 1 squared will also be able to give us 5, and we are multiplying this by sine of theta. So we are multiplying this by sine of theta. So it means 17 will be equal to the square root of 385 times 5 sine of theta. So it means sine of theta is same as 17 out of the square root of 1925. So that is what basically we shall have. So theta will be same as sine inverse of 17 over the square root of 1925. And theta will be equal to, so this will be able to give us the angle as 22.796. So that is approximately 22.8 degrees. So this will be the angle between the plane and the line. So therefore, the angle between the plane and the line is 22.8 degrees. And that will be all about question number 12. So please don't forget to subscribe to this channel so you will always get updated whenever a new video is uploaded. So that is all about question number 12, and now we shall look at the next question. Yeah.